The facility location problem may have very reason and very aspect that should be considered as a facility planner. For instance, if you want to add some new facility, you may use a single facility approach or multi-facility. And for the solution phase, you can apply the continuous concept and also discrete step. For optimizing something, optimizing criteria, you might use three functions just like Minisum, Minimax, and Maximin. And for the representations of the result, it may include the points and also the areas. And for also measuring the distance, it may include the rectilinear, straight line, Chebyshev, and the actual. And for using the adding some new facility, you may use some approach. So let's take a look for the exercise one. Yeah. So we have three facility, and then there is a new facility that will be added in the current facility, but we didn't know that the facility itself should be considered into the proper one. So there are three former facility, F1, F2, and F3, and one new facility should be built, but the location itself consider three former facility that already set in the company or in the manufacturer. And then we have four alternative. We have four alternative that the facility may put in the A1, A2, A3, or A4. Okay, so the new facility may be put into four different alternatives. And then we have a weight. Weight represent a unit load or a single load that should be transferred into one facility to another facility, let's say 1 to 3. So F1 has a unit load or has a weight, let's say F1. So weight itself, it doesn't represent the exact amount of weight itself. The weight may include the importance factor, the unit load, or another unit that will be included in the facility planning. So let's say the weight of F1, F2, F3 is 1, 2, and 3. And then this former facility location can be put in this matrix location distance. And this number represents the locations, the distance, and then we have new alternative locations. So we have one new facility. So this one new facility should be built into four different locations. It may be put into A1 or A2 or A3 or A4. And the travel distance between F1 to A1 is 30. So this number represents the distance. F1 to A2 is 45, F1 to A4 is 70, and etc. Now let's multiply the location by its weight. So F1 has 1 weight, F2 has 2 for weight, and 3 will be included into F3. So 1, 2, and 3. Just time it 1. So 30 times 1 will be stay the same. All the number will be stay the same since the weight number is only 1. And for the seconds, for F2, since the F2 has 2 for the weight, so you can double all the numbers by 2. So it will be 150, 120, 90, and 70. Got it? So F3 will be times 3 since the F3 itself has 3 for the weight. Just time it Just time it into three numbers: 105, 60, 105, and 135. Now, for the facility location, we can use some optimization by using a Minisum, Minimax, or Maximins. Okay, so in Minisum, it means minimize, just minimizing 30, 150, 105. 45 plus 120 and 60, 60 plus 90, 105, and the rest is 70, 70, 135. Just add all the columns in new locations. Okay, I repeat again, just sum up the numbers in each column for all the alternatives, started by A1 to A4. After we do some addition in every single locations, in new single location, and then just find out the minimum number of each locations. So the minimum number is located in the A2, which has 225. So we can put new facility into A2. If we use Minisum, it means we consider all the travel distance for all the current facility, and then we consider again the minimum traveling distance between all the facilities. So we can use A2 as a result. Now, if your purpose want to maximize the minimum traveling distance for all the facility, maximize the minimum traveling distance, it means you just find out the maximum number in each new locations. So let's take a look. In A1, the maximum number will be found by F3. Okay, and then in A1, okay. And for A2, the maximum number is 120. For A3 is 105, and the last is 135. After we know the maximum number, we can use a minimize. So minimize means you just select the minimum number of these serials. So the minimum number will be taken from A3, which has the smallest value, smallest number, 105. So we can put the new facility into A3. If your purpose want to maximize the minimum traveling distance of all new facility. Now, let's take a look at another options. If you want to apply the minimum, find the minimum number of maximized traveling distance. So you just switch the function by using finding the minimum number of every new locations. So every location has minimum number, which is 30, 45, 60, and 70. And the smallest, no, not the smallest, but the bigger number can be found in A4. So we can put A4 for Maximin, or optimizing the minimum number of the largest distance for all the facility. So putting the right or a certain point, it means a discrete. So discrete means you have to put into a certain locations. And for continuous, mean you can put it anytime or anywhere in the area. It doesn't consider any rules, but for optimizing something, it means you should consider the rule itself. The rule will reflect to the purpose of your facility planning, which is Minisum, Minimax, and Maximin.